you're going to have some graphing to start with. You're going to have some substitution. You're going to have elimination. On this one, then you can definitely use your calculator, and you're just trying to match up which one of these graphs, this is a multiple choice one, which one of these graphs matches with the two equations. So you don't necessarily have to find the solution here. You're just trying to find out which one matches up. And so for the first one, we want to get y by itself. If we really want to put this into the calculator, we want to solve for y. And so we get y equals negative x plus 8. The other one is already solved for y, so we got y equals x plus 2. So we're ready to go, okay? And now you can put it in the calculator, and it should be pretty easy to determine because these 4 lines are all crossing in 4 different quadrants. Crossing in quadrants, right? So you should be able to tell pretty easily which one it is. Okay, same thing here, except you don't have the graph, so you have to graph it yourself. Solve both of those for y. And then I would say use your calculator, okay? Now, the thing about using your calculator is you do want to get some points. We want to graph that line, or both of those lines, pretty accurately. So you're going to need some points. You can use your slope, you can use your y-intercept, things like that. I don't have a problem with you using your calculator to graph it, but just make sure your line matches up with your calculator when you put it on the graph. And so if you do have to graph, I got you some graph paper there you can graph. We are solving here, so your answer, remember, your answer is either an ordered pair, it's no solution, or it's infinitely many solutions. If you have an ordered pair, tell me what the ordered pair is. If it's infinitely many or no solution, you just have to say infinitely many or no solution. And it should match up with the graph. Like if they're parallel, it would be no solution. If they're right on top of one another, then it would be infinitely many. Okay, number 3 would be the same way. Number 4 and 5 are both substitution problems. Number 4 is pretty straightforward. We're going to take, since y is already by itself, we're just going to take this and plug it in where the y is in the first equation. Okay, if you already have a variable by itself, and it can either be x or y, just take that expression, plug it in, and then solve it out. If it's not solved for x or y, then like on number 5, I would pick x. I would get x by itself. Add 4y to 21, and then plug it in and solve it. Once again, on all of these, the first 7 problems, you can either get one solution, which is an ordered pair, no solution, or infinitely many solutions. And so even with substitution and elimination, you might end up with one of those special types of solutions. Okay. Elimination, remember we just want the equations to be opposites of one another. If I was going to do, let's take a look at number 7. I would leave the first equation alone for right now. And on the bottom equation, we want to get our equation lined up. So we want x's, and then we want y's, and then we want our constants, right? So we got to move 16y over. So we're going to add 16y. So that would be your first step if they're not already lined up. Number 6 was already lined up, so you were ready to go and do elimination. Now these are lined up, and now we can choose which one we want to get rid of. I can either get rid of the x's, or I can get rid of y's, whichever one you want to get rid of. And so like on this one here, I would multiply by -2. Just make sure that when you multiply all the way through and distribute it to everything. And then put the two equations together. Okay, so on those first 7, I am going to be looking for work. I know that you guys can put that into the calculator. I know you can use matrices on it, okay? And if you want to check it by using matrices, I don't have a problem with that, okay? And that's even what the directions say. Use your graphing calculator to check your answer, okay? I don't have a problem with that one bit, just to make sure your answer works. I mean, you can always take your answer and try to plug it in too. But because it says elimination substitution, I will look for the work on those, okay? On the ones that you are just going to strictly do by the calculator, there really won't be any work involved. But on those, I will look for work, okay, just so you can practice all the methods. On number 8, this is when we talked about the different types of solutions. Consistent means there is a solution. Inconsistent means there's not a solution. Dependent and independent. Independent means the two equations are totally independent of one another. Dependent means they are dependent upon one another, which means they have like the same slope, the same y-intercept, and things like that. Okay, there's only 3 different types of systems, and so we got 4 choices here. The one that will never make sense is inconsistent dependent. Okay, that is the one that I'm going to get rid of right away. Okay, and they may be rearranged on the quiz. It will be a multiple choice question, but these may not be in the same order. So inconsistent dependent is the one you want to eliminate right away. Because think about it this way, if 2 solutions or 2 graphs are inconsistent, that means they don't cross, right? And that means the 2 graphs have different slopes and they will never touch one another. They don't have any points in common. Dependent means they have something in common. Independent means they don't, okay? They're 2 totally different lines, independent of one another. And so this is no solution. This would be one solution, and this would be infinitely many solutions. And for me, I think the best way to try to determine what they are is solve for y. Okay, and these are not solved for y right now, but we want to compare the 3 different equations, or the 2 equations that we have, and then which are the 3 solutions that we have. So if the slopes are different, then it's going to have a solution, right? They're going to cross. If the slopes are the same, but the y-intercept's different, that means they're going to be parallel to one another. And if everything the same, if the 2 equations are exactly the same, then it would be infinitely many solutions. So once you have it solved for y, then you should be able to tell what type of solution you have. Okay. So that would be my hint here is solve both of those equations for y. Get y by itself. Okay. Number 9 is kind of a application problem using all of those different types of methods. And so here, you could graph this, and most of the time we would look at this and say, oh man, this is great to graph because y is already by itself. But because of the big numbers that we have, I would say I probably wouldn't graph this. Because you got 483. You're going to have to change your window to see where this graph crosses. Okay? If the numbers weren't so big, then I absolutely would plug it into my calculator. But because the numbers are larger, and if you want to change your window, go for it. I mean, that would work if you changed your window. But if you don't change your window, you won't see where these graphs cross. Okay? So that's kind of up to you, how you want to approach that. If you want to change your window, go for it. I think the easiest way to do this one is just do substitution, because they're already solved for y. Take 483 minus 3x, plug it in for y, and then all I have to do is set those 2 equal to each other, and then solve for y, or solve for x. Okay. I probably should eliminate this one right away, right? I mean, I know if I see a negative answer, We're talking about like if you run a business, right, then it's like supply and demand. And so if I stock up something in my business, then I want to know like how much am I going to sell of it. If I stock up a bunch and nobody buys it, then it just sits on the shelf, right? So you want to know what the demand is for that. And so that's what we're talking about here. X is the number of items. Y represents the price and how much I make. How much did I spend? And then how much did I make? So the price could represent a couple of different things. Okay, this is another kind of story problem, but everything's been done for you. You just have to kind of use representation here. You kind of have to figure out what's being used and how we're using it. So X is the number of binoculars that we are selling. Y is how much money we're either making or it cost us to buy those binoculars, okay? Or make them or whatever we're doing here. Okay, this point right here is what we call the break-even point. That's where we break even. And so what this means is X represents binoculars. So I have to sell 750 binoculars to make $2,250. That's my break-even point. If I sell more than that, I make money. If I sell less than that, I'm losing money. Okay? So that's what the break-even point means. This is where we break even. So that's my goal. I want to sell 750 pairs of binoculars. I want to sell more than that, obviously, but that's my break-even point. I want to at least break even. I don't want to lose money. But pay attention to the question. Our question here is not an ordered pair. This says, what's the break-even point for cost and revenue? Cost and revenue is dollar amount, okay? Cost, like how much does it cost me? How much is the revenue? How much am I making? That's a dollar amount. If it said how many binoculars do I have to sell to break even, then I would want the X value. But here I want the Y value. So 2250 would be the break-even point for the amount of money. Okay. So it's just looking at the graph and using that to kind of interpret what's going on. Questions on that? Does that make sense? So there's really no work involved there. It's just being able to read it and figure out what you got. Okay, we did one of these yesterday. Okay, so you might want to look back at the example that we did yesterday. I'm going to let you try to do this one on your own. I will tell you this. We have 5% and 10% on this one. So that means there are only two variables. So what I would do here, and I'm going to let you try to come up with the equations on your own, and if you can't figure it out, I'll come around and help you. X is going to represent the 5%. Y is going to represent the 10%. The one we did yesterday had three variables in it. We're going to have one here in just a second that'll have three variables in it as well. But this one's just two variables. Okay. So that means we only have two equations. If we have two variables, we only have two equations. If we had three variables, we'll have three equations. Okay, this one, you can just put it into your matrix. That's the only way we did those types of problems. And remember, it's RREF that we're looking for. If you need help with your calculator, let me know. I can help you with it. Number 13 is the same way. Just plug it into your calculator, use your matrix. Remember that you can still get no solution and infinitely many solutions on those as well. Remember what those look like? That's a possibility. Hey, this one is very similar to the other story problem. So setting it up is going to be very, very similar, except this one has three variables. So I'm going to say this might be my X, this might be my Y, and then this might be my Z. Hey, but remember here you're going to have three equations because we have three variables. And this one is more like the one we did yesterday. The one we had just a second ago, I think slightly easier because you don't have a third equation. This one's going to have the third equation, so it's very similar to the one we did yesterday in our notes. Here we just want to know what's the order, okay? What's the size of the matrix? So that one's pretty straightforward. 16 and 17 are pretty straightforward. This one gives you the equations. We have to say which matrix is correct. This one gives you the matrix. You have to say which equations are correct. So there's no solving or anything like that. It's just which one does it match up with. So there shouldn't be any work involved in those, just matching them up. And then 18 is where we're going to use the stat function, and that's the one we did yesterday. Stat, you're going to put it into L1 and L2, and then you're going to go to stat, you're going to go calculate, and quadrig. Or if it's a Casio, you'll do the x squared, because it says here we want to put it in a quadratic equation. Now, you're going to come up with the equation first, and then 2011 is when I want to figure out how many pounds it's going to be. So I'm going to put in 2011, it would be 3 years past 2008, so I'm going to put 12 into this equation and figure out how many pounds it would be. Okay. But you can do all of that in the calculator. Okay, questions so far? Okay, I'm going to let you guys work if you have questions. I just did post answers to 616263. You can check those out if you want to. I meant to do it last night. I scanned them in last night, but I forgot to post them. So they're up now for you. And I'll get this posted before I leave today as well for the review.